Hey, welcome back, students. Okay, so today, as you guys can see, because of the potential threat of the coronavirus, we're not taking any precautions today. So we have Purell N95 mask, anything that, and even colored pens. I mean, come on, how could you not fight the coronavirus without colored pens? I mean, this is the best thing ever. Okay. So last day, what we did, we spoke about why LCM is important. We said that LCM itself, it wasn't that important of a topic on its own, in that you would not get questions that would give you a lot of marks with regards to LCM itself. However, LCM is necessary for more important functions like adding fractions, subtracting fractions, and much, much, much more. So just a slight recap. What we did last time, we showed there were two methods of finding LCM. The prime factorization method, where we listed out all of the multiples of a particular number, as well as the division method. And we said for the essay exam, we would use the division method because of the fact that it was easier. It is less guesswork. And for bigger numbers, it would actually be much, much, much shorter. So what we're going to do, we're going to proceed to do a couple more examples of calculating LCM. Now, a bit of things that we were thinking about. Now, the first one was that we were going to send all of the videos via WhatsApp. However, WhatsApp has a 1 gigabyte limit. And the thing is, WhatsApp compresses the videos. So a lot of things, for instance, text, you will not be able to see it crisp, it wouldn't be clear, you would not get the full video experience. So now what we've decided to do is we took my channel, the YouTube channel Hacker7, and we changed it to be in a private channel. So only people with invite links would be able to get access to it. Like I said in the video, the post that I put on Facebook itself, this is kind of like, when they had the Match Grand, the Panorama Finals, how they were trying to broadcast it online, and well, long story short, it did not go as planned. This was about, 5-10 years ago, before some of you guys were born. Okay, so let's get into it. So calculate the LCM of a quarter and 1/6. And recap, in case you guys were watching like a lot of TV, playing PUBG, playing Fortnite, playing Minecraft, what we were saying was that with fractions that have the same exact denominator, like for instance, if we had, oh, by the way, like watching through the camera view, finding writing is so difficult. So bear with me in case like I write nonsense. All right, so if we had like a quarter plus 2/4, then because we have the same exact denominator, so again, we did this in class, but for students who weren't with us or who were absent on that day, we have the numerator on top, and then we have the denominator below. So if we have a pizza, we divide the pizza into 4 equal slices. The denominator will be the 4, so it will be 4 equal slices. And if Dimitri eat one slice, it would be represented as that 1/4. And if we had a whole pizza, and the whole pizza would be 4 out of 4 slices. So just an example of a question, if we subtract in fractions, if we have a whole pizza, which is 4 to 4 slices, and then somebody eats one slice, then we would be left with 3 slices, 3 out of 4. Numerator on top, denominator below. Now the reason why I'm not going through the nomenclature or the naming of a lot of these things is because we already did this in class. If your student was with us, it was probably about within the last 2 months, they have this huge mega handout that took me about 7 hours to prepare, and we gave it, and we used 2 sessions and we covered this in detail. But even though students are decent with fractions, I'm still not 100% happy with the calculation of LCM. So that's the reason why we're going to do a lot of revision this weekend. I want to make sure students are up to par, up to scratch. I want to make sure they don't make these simple little mistakes for the essay exam. And for ones now joining us, I want them to have a understanding of it. So the thing is, we're calculating the LCM. So in the first event, we have the same denominator. Because we have the same exact denominator, we don't really have to worry about getting a same denominator to add. We just add or subtract the numbers that are on top. However, in this example, we can actually see that 1/4 and 1/6, they have a different denominators. Their denominators aren't the same. So what we have to do is we have to convert a quarter and 1/6 into equivalent fractions in which they have the same exact denominator. So instead of 1/4, it will be a numerator over next number, and then a numerator over next number, and it will basically, the new fraction would be the same exact as a quarter. It'll be the same exact as 1/6, except now they have the same exact denominators. Now, let's use it two methods, just as a recap, in case you guys eat too much KFC or Pizza Hut, and you guys totally forgot about the last video. So the first method, so LCM, you have two methods. You have the prime factorization method, and then you have the division method. Whoa. Okay, watching through his camera lens and writing is so trippy because there is a delay. So, okay, the division method. So prime factorization method would be to list the denominators. So we have 4, we have 6. So now what we're going to do, we're just going to list the multiples of them. So it'll basically be the number itself plus itself again until infinity. And what we would do, we would choose the first number that is in common with both of them. Now, I'm still recording in Quad HD. I'm not too sure if there's a 10-minute cap on it, but we will see. We're actually at 6 minutes now. So we have 4, we have 8, we have 12, and we just add in 4. So 4 plus 4, 4, 5, 6, 7, 8. 8, 9, 10, 11, 12. 12, 13, 14, 15, 16. 16, 20, 24, 28, etc. So now we're going to do the same exact thing with the number 6. So we have 6, we have 12, we have 18, we have 24. Now, you guys could notice something. We have 24 here, we have 24 here. But that is not the lowest number in common with both of them. What is the lowest common number in both of them? Aha. Hey, I actually had a chemistry teacher back in Form 6 called Dr. Medford, and whenever he found the equation to a particular question, he would be like, aha! I'm actually now starting to understand why he did that, because it is actually kind of cool and dramatic to say, aha! So, tribute to Dr. Medford. Aha! 12. Okay, so we have 12. So essentially the LCM using the prime factorization method is 12. Now, as you guys can see, in this case, it is lucky because we have two numbers that are really similar, but we could get a lot messier with this. And I'll give you guys examples as we move on, as we progress, to show you guys why this method is not ideal. So this was the first method. This is prime factorization. Let's go on to the method that you will use for the essay exam to pass your school of choice and come in top 100 and bring glory to elite educators. All right, so... all right, so the other method would be the division method. So we put the denominators, we put 4 and 6. Now remember, we're just trying to find a number common to both of these so that we can actually use it as the new denominator. So what we're going to do, we're going to put the lowest possible number that can be divided into 4 and 6. We start with 1. 1 will not do anything for us because of the fact that if we divide by 1, we'll get 4 and 6 and we'll be in an infinite loop, just like Doctor Strange was when he went to battle the last boss in his movie. He'll be like, Dormammu, I've come to bargain. Dormammu, I've come to bargain. So yeah, if anybody who see Doctor Strange, you guys might get a reference. So let's try the next one. The next one is numero dos. That's number 2. So essentially we're going to put number 2. In some cases it will work, some cases it will not work. In this case it does work, and it works on both numbers. If, for instance, we had a number that was not divisible by 2, we would just leave it. We'll just bring it down. So if we had 3 here, we're just bringing them down. We were not going to divide or anything like that because we have to get a number that will be, we could divide by these numbers without having a remainder. Ooh, we're at 8 minutes and 46 seconds. Let's see what happens in 1 minute in case Quad HD decides to cut off. So 4 divided by 2, and I will choose someone. Rishi, what is 4 divided by 2? Okay, it's 2. Okay, there's no students here, but okay, in class we would probably do that, so I'll just point randomly at somebody. Alright, 6 divided by 2 will give you 3. Now, 2 again will work here, so basically 2 divided by 2 will give you 1, and once you have that 1, that is the end for this particular side. That is Avengers Endgame. So once you have that 1 there, you have nothing to worry about. Now, 3 cannot divide by 2, so we just bring down the 3 itself, and obviously 2 cannot work here anymore, so we use 3. I'm noticing a lot of autofocus issues. I may use the iPhone for the next recording. So we have 1 there that's finished already. 3 divided by 3 is 1, so that's it. So what we do, we take these numbers. Okay, looking through the viewfinder is trippy. And we just multiply. 2 multiplied by 2 multiplied by 3. 2 by 2 is 4, 4 3 is 12. And guys, we got the same answer. Okay, so push this Purell. Don't fall off the table. Don't fall off the table. Don't fall off the table. Okay, so now what we're gonna do is we're just gonna use the information that we have. So okay, that was purple. Alright, we're in your live chat. I need some input. I'll ask you guys what color should I use next. Okay, so essentially we have a quarter, and we have 1/6, and we have the LCM as being 12. So in order to make these equivalent fractions, what we have to do is we have to say, okay, 12 divided by 4, so 12 divided by 4, that will give us 3. Alright, so 12 divided by 4 is 3. And then we see 3 multiplied by the numerator. 3 by 1 is 3. So therefore, 1/4 is equal to 3/12. And in this case, we have the LCM. Okay, well, this is just LCM, but we could do addition, we could do subtraction, and we already finished that part of the equation. Anyhow, let's pretend it was, the question was add a quarter and 1/6. So 12 divided by 6, so 12 divided by 6 equals 2. So 2 multiplied by 1 is 2. So 3 plus 2 equals 5/12. So there we have it. We just basically did a question that was supposed to be adding, and which was supposed to be just finding the LCM, but we did addition as well. We will go into some more advanced topics now. Yes, it has crossed the 11-minute threshold. That means that we could continue recording, so you guys wouldn't have to click a link every single 5 minutes. Okay, so again, what I want to exemplify, I want to show you guys here is that 1/4 is equal to 3/12. That is actually what we did here by that whole 12 divided by 4, 3 multiplied by one thing. So essentially, if you divide 3 by 3, 3 divided by 3 is 1, 12 divided by 3 is 4. And also, I want to show you guys 1/6 is equal to 2/12. Because 2 divided by 2 will give you 1, 12 divided by 2 will give you 6. So therefore, what we have here is an example of LCM, as well as an example of how we're gonna do that for addition. So I want to make sure this focuses, so in case you guys were taking notes or anything like that. Mr. Runa has already typed up the notes, but most likely we'll have to find a method to send it to you guys via WhatsApp. So I just want you guys to see this. In case you guys were making notes, I'll just leave this right here. All right, let us go on to page number 2. Now this might seem wasteful because of the fact that I'm like literally using a new page. But why not? It is for you kids. I shall follow suit. Okay, so let's do another example. So let's calculate. Okay, so I'll try to write as big as possible. Calculate the LCM of, and we'll put 1/3, 1/2, and 3/5. Now, the thing is, if we just have to calculate the LCM, if we have to find the LCM, we do not use the numerator, which is the top number, right? So in the event that we just have to calculate LCM, we do not have to look at the numerator. We just have to look at the denominators, right? The numerator is only important if we have some sort of further future calculation. If we need to add them, if we need to subtract them, then we look at the numerator. But if the question just asks us to calculate the LCM of this, all we need to do is look at the denominators. So, okay, we put them 3, 2, 5. So I tell kids all the time that what we can do is we have certain things that we could do without even having to